name, Ma'am Julia Poniente. I am Aiza Nodalo.
I am Sophia, Francine, Formentera.
We are here to present our topic, which is Lesson 9.1. It's all about electrical charges. Since 600 before Christ era, humans have been aware of the handling ability of some natural substances or materials. Thales of Miletus investigated the ability of amber to attract nearby objects when rubbed with a piece of cloth. In 1600, William Gilbert found that many other materials when rubbed against another material exhibit the same ability of amber. He coined the term electricity from the word electrons, Greek word for amber, to associate to this observed property. Lodestone, now known as magnetite or magnetized iron ore, is another substance with a somewhat similar property. It can attract iron even without rubbing it with another substance or material. Magnetism, this ability is to attract iron, and the materials having this property is called magnets. Again, magnetism, this ability is to attract iron, and the materials having this property is called magnets. Were initially thought to be separate phenomena. However, succeeding discoveries showed that they are very much related. One cannot exist without the other.
Nature of charges. Scientists explain the nature of electric and magnetism and other related phenomena using the concept of electrical charge. Today, the study of electric charge is divided into two subfields. Electrostatic studies the phenomena associated with charged particles at rest, while electrodynamic studies those involving moving charges. In 1952, Benjamin Franklin conducted experiments using glass pot rubbed with silk and rubber rod rubbed with fur. He observed that the two rods repel each other. The two rubber rods also repel each other, but the glass rod and rubber rod attract each other. Franklin concluded that there were two types of charges: the charge of the glass rod, which he designated as positive, while the rubber rod as negative. Positive and negative charge are the two types of electric charges. In line with this, Franklin also formulated the law of conservation of charges, which states for an isolated system, the sum of the charges before and after an interaction must be constant. The ability of materials to attract or repel other materials is explained using the concept of electron gain or loss during an interaction. A material may gain electrons and become negative charge, or it may lose electrons and become positive charge. Materials with like charges repel each other. Those with unlike charges attract each other.
A hypothetical body or particle as a material. Its charge, represented by Q, is usually expressed in the SI unit column, abbreviated as electrons and protons, which are subatomic particles. Its charge values of 1.6 times 10 to the power of negative 19 C and 1.6 times 10 to the power of positive 19 coulombs, respectively.
A problem. In this problem, we have two spire. Spire A and spire B with charge of negative 3.0 coulombs plus 2.0 coulombs. Respectively, we are asked to determine the number of electrons that must transfer from spire A to spire B in order for them to have equal charges. To solve this problem, we'll use the principle of conservation of charges, which states the sum of charge before and after an interaction must be constant. Let's assume after the electrons have been transferred, the final charge of each spire is represented by Q. According to conservation of charges, the sum of charges before the interaction should be equal to the sum of charges after the interaction. The sum of charges before the interaction is negative 3.0, which give us 1.1. Sum of charges before an interaction is negative 3.1 C plus 2.0 equals to 1.0 kay negative 1 plus 2 is 1 mo ni siyang nahimog Q na lang dili kay. And C thinks is equal to the sum of charges after the interaction is 2Q. Nakakuha tag 2Q kay i-plus nato ang QA and QB. Mo na siya ang nakuha tag 2Q. And to find the value of Q, we divided both sides of the equation by the Q and 2Q, which equals to negative 0.5. Now that we know the final charge of each spire, we can determine the charge of spire B. The change in charge is given by the final charge minus the initial charge. So the change in charge of spire B is negative 0.5 C minus 2.0 C equals to 2.05. To calculate the number of electrons transferred from spare E to spare B, we divided the change in charge, negative 2.5 divided by negative 1.6 times 10 to the power of negative 19. So, nakakuha tag negative 1.6 times 10 to the power of negative 19 kay mo ni siya yung kuan sa electrons. I-divide na sila, then negative 2.5 divided by negative 1.6 times 10 over 19 equals to 1.5625 times 10 to the power of negative 19.
Objects with like charges repel each other, while those with unlike charges attract. Consider two stationary charged particles separated by distance t, as shown in figure 9.2. These charged particles are so small that they can be considered as point charges, with magnitudes Q1 and Q2. If Q1 and Q2 have unlike signs, dili sila parehong signs, they would exert an attractive force to each other. Pag dili sila same og sign, mag-attract sila. The force exerted by Q2 on Q1 equals F21 is equal to the force exerted by Q1 and Q3 is F21. If Q1 and Q2 have like sign, they would repel each other. If same silang sign, mag-repel sila. In this case, F21 is equal in magnitude but opposite direction to F21. That is, F12 equals negative F21. The attractive or repulsive force experienced by each point charge is directed along the line between them. French physicist Charles Augustin de Coulomb, who conducted experiments to determine how the force of attraction or repulsion between stationary charged particles is affected by the magnitude of their charges and distance between them. The result of his experiments was the law that now bears named Coulomb's law, which states that the magnitude of the electrostatic force exerted by a point charge on another point charge is directly proportional to the product of the magnitudes of their charges and inversely proportional to the square of the distance d between them. So this is the formula of the Coulomb's law, where F is electrostatic force, where E is a proportional constant with a value of 8.99 times 10 to the power of 9 Newton m squared over c squared, and Coulomb's unit, Q1 over Q2, Q1 and Q2 over distance. This value is usually rounded off to 9 times 10 to the power of 9 Newton m squared over c squared, because nahimo siya 9 because pag-round off is 9 naman iyang tapat, so mahimo na ang 8, it becomes 9. Tapos ang 9 kay 9 iyang kasunod, so mahimo na siyang 10. Maong 9 times 10 to the power of 9 Newton m squared over c squared.